Hello. This video is to help demystify the dreaded topic of dun 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 significant figures. We're going to learn this using what's called the Atlantic-Pacific method. Here we have a map of the United States, and as we all know, the Pacific Ocean is on the west or left coast of the US, and the Atlantic Ocean is on the east/right coast of the US. If a decimal point is present, and notice the word present starts with P, you start from the Pacific side. This means you're going to scan the number from left to right. You won't start counting your significant digits until you reach the first non-zero number. For example, if you wanted to determine how many significant digits were in this number, you could use the Atlantic-Pacific method and it would be a cinch. Since a decimal point is present in this number, that means we're going to start from the Pacific side, meaning we're going to scan this number from the left side to the right side until we reach the first non-zero digit. And as we're going from left to right, our first non-zero digit would be this 8. So we're going to start counting our significant figures from the 8 on to the right of it. So the 8 would be the first significant digit. The 2 would be the second. The next 0 would be the third. The next 0 would be the fourth significant digit. On the other hand, if the decimal point is absent, and notice the word absent starts with an A, then you're going to start from the Atlantic or right side, which means you're going to scan the number from right to left until you reach the first non-zero digit, and then you will start counting significant digits. For example, if you wanted to determine the number of significant digits in this number using the Atlantic-Pacific method, you would first look and see if there's a decimal point. Now notice with this number that there is no decimal point, meaning the decimal point is absent. And you would start from the Atlantic or right side and work your way all the way to the left. So as we're doing that, as we're scanning the number from right to left, the first non-zero digit this time is the 3. So that would be our first non-zero digit and our first significant digit. The second non-zero digit is the 5. So that would be our second significant digit. So this number, although it has 6 zeros after it, only has 2 significant figures. Now what if you have a problem in which you're adding or subtracting numbers with different numbers of significant figures? How do you determine how many significant figures your answer should have? That's also easy, and you don't even need the Atlantic-Pacific method for that. I'm quite sure that your teacher is going to give you the snuggle bear face if you ask him or her how many significant digits your answer should have, because the numbers that you use in the problem automatically tell you this answer without you even having to look at your teacher. Now for some practice. If you are multiplying or dividing and you want to know how many significant figures your answer should have, there's no need, once again, to ask your teacher, because the numbers in the problem tell you all the information that you need. For example, if you had the problem 2.89 times 3.1 and you typed it into your calculator would give you a number that looks like this, 8.959. Now, the question is, do you use all of the digits that your calculator gave you? And the obvious answer to this question would be no. What you're going to do is you're going to have your answer match the number of significant figures that the number in the problem with the least amount of digits has. Now, out of these two numbers, 2.89 has 1, 2, 3 significant digits, and 3.1 has 1, 2 significant digits. So since 2 is smaller than 3, you're going to use 2 significant digits in your answer. So we're going to go to the second digit. You know you're going to use the 8, and you know you're going to have a second digit. However, in order to determine what that second digit should be, because you're going to have to round, you have to look at the third digit. Now, as you recall from the rounding rules you've learned, if a digit is 5 or above, you round it up. And if a digit is below 5, you round it down. Since the digit to the right of our 9 is a 5, this would require us to round this 8.959 to 9.0. Now, if you're adding and subtracting, really the same rules apply. Your answer should have the same number of significant figures as the number in the problem that has the least amount of significant digits. For example, if you're adding 3.854 plus 10.32, and you type this into your calculator, you're going to get a number that looks like this, 14.174. Now, if you want to know how many significant digits your final answer should have, you go and you count the number of significant digits that each of the numbers used in the problem has. So 3.854 has 1, 2, 3, 4 significant digits. And 10.32 has 1, 2, 3, 4 significant digits. So how many significant digits did your answer have? Yep, you guessed it, 4. So this 14.174 should be rounded. Now we know we're going to use the 1, the 4, the 1, and we're going to have a 4th digit. Now in order to determine whether we should round this 4th digit up or down, we need to look at the 5th digit. The 5th digit is a 4. And using our rounding rules, that means that we round down. So our final answer should be 14.17. See? That was pretty easy. These are literally the only 3 rules you need to remember in order to be able to do anything you want with significant digits. See you next time.